Hello, everyone. Hope you enjoyed the Around the Clock with Azure SQL and Azure Data Factory events, and welcome to join this session of Data Ingestion Performance Optimization. This is Linda Wang. I'm the program manager from Azure Data Factory team. So in this session, for the next 20 minutes, I'd like to cover the following aspects around the data ingestion. To start with, we will talk about the key scenarios that we are seeing that Azure Data Factory empowers customer to do. And we'll talk about the breadth of connectivity that ADF can reach a rich set of data stores for data movement need. And we'll also share some of the performance features and best practice for respective workloads that you may have. And last, we will talk about the general performance tuning steps, which will help you assess the performance to meet your performance expectation when you build the solutions. Let's start with the data movement scenarios. So as you may know, Azure Data Factory is a fully managed data integration service on Azure, which has a rich set of capabilities. And the data copy or data movement, data ingestion is one of the most important capability and also being used by a broad set of customers. And when we see the customer come to with the data movement scenario, it mainly fall into the following two key scenarios. The first one is the data migration for data lake or EDW, the enterprise data warehouse. That if you already have some big data workloads on either on-prem that you want to move to the cloud, or you are having such workloads on other clouds, and you want to adopt the evolving and advanced analytics solutions or data services on Azure, then you may want to move the data around, either from the file-based stores for this big data, the data lake, or from the EDW. And here, ADF helps for this scenario. Basically, we provide a highly scalable and performance solution for such data movement, and it's a pay-as-you-go manner, which is cost-effective. It can handle both the initial snapshot and the incremental catch-ups. Another scenario is we call that as data ingestion for a cloud ETL, or you say ELT, where you bring the data from a variety of sources onto a lake, and on top of which you can use the code-free or code-based transformation, like the data flow transformation, or some other is the SQL store procedure or Databricks Spark notebook. Then after the transformation, you may want to push the data, the analyzed data to either DW for reporting, or you want to empower some apps running against these results. So ADF provides resetable connectors, the hybrid connectivity, enterprise-grade security, and also ease of monitoring and productivity. Then with all those scenarios, ADF support a rich set of connectors. It's 90 plus, and this is just a snapshot, and this is keep growing. It covers almost all the Azure data stores, the common database data warehouse, rich file storage, and the long list of the service and the SaaS applications. So this is just give you some idea on which data stores we can reach. Well, if your data store is not in that list, actually no worries. The previous list is just first-class connectors, and we also support some generic protocol connectors to help you reach much more data stores than what is called out in the previous slide. So we have generic ODBC, REST, HTTP, OData, all etc. that can help reach other data stores, even not in the list. And also you can use ADF's flexible orchestration and control flow, and also integration with other Azure services, all the REST capabilities to invoke other your customized data loading mechanism, and ADF can orchestrate the entire workflow and move the data for the rest of the flow as well. So with this capabilities, next I'd like to share more about what is the runtime that empowers the copy, and also some of the features that really happens underneath when you construct a copy activity to move from data store A to data store B, so as to demystify the copy activity, how it works. So to empower the copy, we actually have two flavors of runtime. The first one is fully managed runtime. We call that as the Azure Integration Runtime. This is a highly elastic, serverless, and pay-as-you-go kind of compute. It's fully managed by Azure Data Factory, and it can access both the public accessible data stores, and also we support the managed virtual network, which is to access the data stores on Azure via the private link. So when you use this flavor of the integration runtime, for each of the copy activity, you can configure how much machine power you want to use so as to empower this data movement. That machine power is represented as a data integration units. This is a combination of CPU and memories, a kind of the virtual concept of that. And by default, ADF also will assess your workloads, either, for example, is your file size or data size, the file count, or etc. Then we will spin up the fitable DIUs by default, and that is a dynamic value, so as to more fit to your specific workload. While if the default behavior doesn't meet your needs, you can further adjust that, for example, to increase this DIUs to bring more powers to so as to make your data movement faster. In addition to this fully managed runtime, we also have another flavor. It's called self-hosted integration runtime. This is one of the agents that you can download and install on a machine, either on-prem or in a VNet. This type of integration runtime is more fitful when you have you doing the hybrid data movement, for example, from on-prem to the cloud, or to access some data store behind the firewall. So this agent can give ADF the line of sight to access your data store in a secured manner. So this agent that you installed on your side is that we do support the auto upgrade. So you install agent, we will push the latest bits to that thing, so you don't need to worry about the maintenance for that. And also to use that to empower more hybrid data movement workloads. You are able to scale out the nodes to up to 4 nodes. Then all those nodes will become active to pick up and run the jobs to move data around. And also for on each of the nodes, there is a concurrency that it can handle multiple copy activity runs. So with the 4 nodes, you can actually run quite comprehensive data movement workloads to move the data for your scenarios. So besides these two flavor of the runtimes, then let's take a look at how the copy activity actually retrieve the data from the source and write data to the destination. So that integration runtime is actually, you can view that as the copy engine. What that engine is doing is it will, based on your configuration, connect to the source data store, retrieve the data, do some of the needed code transform, like the deserialize, serialize to files, or do some column mappings, or etc. Then to make the data compatible with the sync formats, then write the data to the sync directly. So while we have 90+ data stores, we can mainly categorize that as 2 categories. One is the file-based stores, the other is non-file-based stores, just as a high level. So within each of the this is talk about within each of the copy activity run, how the copy activity behaves, and later we will also talk about how it scales to larger workloads. So each data store may have some specific tactics or characteristics on special tuning, but here what we talk about is can be a general practice that applies to this flavor or this type of the data stores. So for the file sources, copy activity within each execution can in parallel copy and parse module files from the source. For example, you point to a folder, there are thousands, millions of files. We'll actually load them in parallel, both at the file level and also within each file. We are partitioning, load the chunks in parallel. And those kind of workloads can be running across the integration runtime DIUs or self-hosted IR nodes, so as to leverage more machine power to really execute this copy. And there's a concept called parallel copy. This is applied to all the copy scenarios. This mainly indicates that how many files to copy at a given time. So some tips when you load data from the files. When using the Azure integrated runtime, you usually can start with the default DIU, which means you let the Azure Data Factory to detect and determine that based on your file pattern. This is especially helpful if you have dynamic folders or data to load, and we can apply different settings based on that. And also, to load from files, we actually support multiple ways to identify the files, like you point to a static path or file name, or even wildcard filter, or etc. So you basically you pay attention that you'd better point to the exact files to copy instead of filter enumerating a large number of files. And to copy to the file sync, you can usually just use the default parallelism and also let ADF to smartly determine that. Usually it can give you a pretty good performance already. And to copy file as this, you can avoid ADF to parse the file. You can choose the binary data set. And to copy to non-file sync, for example, the Azure SQL database, you can increase the degree of parallelism, which is to enable the parallel write to the destination, so as to increase the throughput for that. Then we come to how to extract data from the non-file sources. This can be any other like database NoSQL SAS application. So usually you retrieve the data based on a query or table name of that. And for the listed data stores, especially including the Azure SQL database, SQL Server, or etc., we support the built-in parallel, the partition, to read the data in parallel, to retrieve the data, and also apply to the destination. This is the way that we can boost the performance to load data faster. And you can further tune that how many parallel partitions or parallel reads to establish during your copy, based on the parallel count. And even if the data store is not in this list, that it doesn't have the built-in partition, you can still leverage multiple copy activity runs, each tackle part of the data for a huge data load. Then this way is also a common mechanism to divide and conquer to load the entire data set much faster. So when you build a solution, usually we see customer or suggest customer to go through this kind of workflow. So first, please assess and understand your needs better. So there are a few categories to consider, like the connectivity, what kind of the source and sync data store and formats you want to move data around. And what is the network considerations requirements? Is that on-prem in a virtual network? Is that public accessible, etc.? And also, is that a historical load or incremental copy? That will imply difference, and also for the size and number of objects, files, or etc. So this will kind of form a workload assessment. And also for security and performance expectation, what is your data loading window for a given workloads? And then based on the previous mentioned connectivity, the features, you can do the functional POC to make sure the functionality works for you. Then we come to the performance POC, which is more related to this section. So when doing the performance test, we usually suggest you can pick a representative workloads. By representative, it can be moderate size, but it's really your real, for example, the data schema, the folder structure that can be used to really evaluate the real perf. And it can run for a longer time, for example, more than 10 minutes, otherwise just to avoid some noise of the startup time. Then based on that, and based on your initial configuration, you can actually get a baseline throughput. And you can use that to compare, okay, if I use this throughput to scale to tackle my entire workload, will that really meet my performance expectation? So also based on that, you can identify your performance bottlenecks. We will talk about how to do that later. Then to really solve the bottleneck and iterate to tune the configuration and get the baseline again. So based on this kind of iteration, you will see a faster throughput and which can meet your needs. Afterwards, you can scale to your entire data set to tackle your entire scenario based on what you tested. And there's always a balance between, do I need to maximize the single copy activity or the aggregated throughput across the objects or data stores? Actually, the latter is more important for an end-to-end solution. So when you do the performance test for single copy activity, you don't need to test all the combinations, which is waste of time. So based on some, we by default will provide some moderate throughput already. You can tune and get to a stage that is good enough for your case. Then you can test the end-to-end solution to get the baseline of that and further tune that perspective as well. And we talk about one of the key steps is to, during the performance test, how to identify the bottleneck. So this is one of the monitoring view for a copy activity run. This is for any of the source to sync copy. Actually, you will see a similar view of this. So what this view is showing you is what is your source data store, how much data being read and write from the source to the destination. It includes, if it's file-based store, you will see files in addition to data size. And also you will get a throughput number, which is the end-to-end throughput calculated by the source data size divided by the copy duration. And also the bottom part, you will see a more detailed breakdown, which help explain that during this copy execution, what exactly happened. So what is the, for example, the data integration units or the parallel copy numbers being used for this copy, and also the duration breakdown, like how long is being queued versus being transferred. And within the transfer, how long is used to retrieve data from source versus writing data to the sink. So for this kind of breakdown will really help you understand what is the bottleneck from your this specific copy activity run. Also, you can see that on the very top, the purple box, we already based on this execution to show you some automatic performance tuning tips. So usually, if you see these tuning tips, you can just follow this thing to make the adjustment of the settings. Usually, the perf tuning tips imply some configuration that is outside of the ADF control. For example, we found that your data store becomes a bottleneck for the data loading, or your self-hosted integration runtime is not don't have enough capacity to run large large number of activities or the large workloads. So you can follow this performance tuning tips to adjust that. And if there's no performance tuning tips, then you follow this detailed duration breakdown. We also have a quite detailed performance scalability guide or the troubleshooting tuning guide, which explains that for each of the duration, if you see that being the longest, what's the possible causes and how to adjust the settings or some other areas so as to make that shorter. So that is a good reference for you to solve the performance needs. And also, we are collecting your feedback on how you experience the performance for the copy activity, whether that meets your need or not. So welcome to give us feedback as well. While previously we mainly talk about how a single copy activity works, now I also want to share how ADF in general overall scales to handle massive data movement across the data stores. So this is like a view that, for example, you have a bunch of data stores that you want to move data around. It can be sitting in the cloud or on-prem, various sources and destinations. So what you use ADF is inside ADF, you construct a pipeline which represents a workflow. And inside it can be a copy activity, point to your source and a sink. And the copy activity will be running on the integration runtime. The IR is the short form for integration runtime. That it may be two flavors, the managed version or the self-hosted version. Then the IR will reach the data stores, different data stores and different data, IRs based on your configuration of which one to use. Then this is a bunch of the areas that ADF is really can scale very well to handle your workloads. So from the very top, ADF provide a very flexible control flow that can help you schedule a large number of copy activities, and they are a flexible trigger as well. So you can run, and also the concurrency support. So you can run a number of activities at the same time to tackle different data stores or different portion of your data. While the job is running on the IR, as mentioned previously, you can configure the DIUs for managed IR or the nodes for the self-hosted IR to scale the integration runtime. And also you can configure how many concurrency to run it on the self-hosted IR as well. Then within each copy activity, as mentioned previously, we also have the parallelism within each copy activity run so as to read the data in parallel as well. So with all those different capabilities in mind, so you can easily use the Azure Data Factory to copy data from 90 plus sources to the destination and vice versa. And also it can tackle large number of data volumes with in a performant and effective, cost-efficient manner as well. So this is how the copy activity can fulfill your data ingestion need. And for the performance tuning, again, you can try with the single copy activity and scale with the control flow and all the surrounding capabilities ADF provides so as to really copy data efficiently for your entire workloads. So I know it's a lot to cover within 20 minutes. So this is a high-level introduction to help you better understand how copy activity behaves and some of the magic code underneath. And we have more detailed documentation and the guides that just put that as a reference. And you will get this deck and also the recording after the event ends. So hope you find this helpful and enjoy the rest sessions in the APAC sessions. And hope you have a good day or good night.